Good morning. Whoa. It's like being in a U2 concert or something. It's like really echoey. Well, good morning. My name is Michael Howard. I'm the security program manager on IIS. I'm the poor sucker who has a really rotten week whenever anybody finds a security bug in the product. Kind of sucks, really. Believe me, it really does ruin my week, so please don't find too many problems. First of all, a couple of little house rules that you all should be aware of. First of all, the speaker and presentation evaluation. Let me explain my little rules. Number one, it's a very simple litmus test that you can actually apply at the end of this presentation. You can safely say that if you walk out of this presentation and you do not understand anything I talked about whatsoever, you have every right to go very low quality, not at all valuable, not at all useful, not at all important, and so on. However, if you walk out of here and you feel like you kind of understand a little bit more, and you sort of feel compelled to look at this stuff, you have no option to go very high quality, very valuable, very useful, very important, high rating, etc. So I'm glad we've got that little rule set up. And I have some very big friends at the back who enforce this policy. First of all, before I get started also, is my buddy Van in the audience? Yep, there's Van. How many of you went to Van's WebDAV presentation yesterday? How many of you stayed awake? You're lying. No, seriously, Van's my buddy. Van's my friend. He's a good guy. But one thing I'll let you know, he actually sits in the office right next to me. And he stole my presentation. He stole my scenario. I'm very bitter. Very, very bitter indeed. And what really sucks is he stole my scenario, and then he went before me at TechEd presentation. So it sounds like I stole his scenario. But let me set the record straight. It is my idea, not his. So anyway, that said, moving right along. The agenda is actually very, very simple. What are the problems we're trying to solve? And to be frank, I would always consider myself a pretty pragmatic guy. I don't like just looking at the pure technology that underlies this stuff. It really depends on the problems you're trying to solve. Then we'll look at what's a certificate. And then finally, we'll look at some ingredients to make up a solution. And then we'll look at baking a solution based on some of those technologies. So what's the problem? Well, building secure web apps and web solutions and secure web solutions in general is extremely difficult. Let's be quite frank. There's lots of complex technologies, and certainly Windows 2000, even though it's got a lot of really funky new security features, some of them are complex security features. So a lot of complex technologies, some of them have historically been difficult to implement. One of the worst things is it's very hard to hide this complexity from the end users. Something we see all the time is that a lot of this security stuff is pasted onto the application after the application has been built. And to be quite frank, you just can't do that. And finally, there is a dearth of skills in the marketplace. People really don't understand security. I mean, to give you an example, I was in San Diego last week, and I was speaking to a woman who asked me to evaluate their security architecture. So after I charged her like $1,000 or so to look at this piece of paper, I went through it, and I think I forced her into early retirement. Everything she put forward, like I said, well, have you considered this? Have you considered this? People can get in this way. What happens if? And she said, well, they're not security problems. So I said, well, how many people do you have working in your organization? And I thought she was going to say like 20 or 30, but she said 100,000. So I thought, well, the latest figures by the so-called consulting groups say that between for every 7 to 10,000 employees you have in an organization, one person is working for somebody else, which means that you have around 10 people working for the competition, working for somebody else. Anyway, like I say, I think she walked away a little bit kind of scared. But there's some things you just have to consider. And it's not until you sort of have a few of these war wounds that you realize just how evil some people can actually be out there. So building a secure web app means, first of all, analyzing your threats. You don't just sort of say, well, it's just like glue security into the system. That's a complete waste of time, because you may be gluing security into completely the wrong place. If you're putting all your security over here, but your threats are actually over here, you're in trouble. And let me just give you a very simple military dictum. There's some guy, a Prussian general by the name of von Clausewitz, in a brilliant book called On War. I highly recommend anyone who's doing any security work to read On War. It's like the modern version of Sun Tzu's Art of War. And he has this military dictum called the position of the interior. And basically the position of the interior really sucks. What it means is that if you're in the defensive position, in other words, you're the guy who built the web app, you're the guy who deployed the web server or something that's on the web, you're on the position of the interior. What that really means is that there's all these really evil guys on the outside, and you've got to defend against them. Now you have to defend against every single possibility, and you have to spread your troops very thin around the perimeter. However, the evil dudes on the outside, all they have to do is find one weak spot. That's all they have to do. And that's known as the position of the interior. And that's where you've got to start analyzing your threats, find out where you are most vulnerable. So then once you've finally worked out where your threats reside, you then need to start applying technologies to cope with those threats. Finally building the system. I see a lot of people who actually say, well, here's some technologies, let's just go and throw it at the problem. Rather than the other way around. What's the problem? Now let's go and find the appropriate tool to solve that problem. And finally, you need to weigh the risks. What are the risks if your system is breached? And there's some that are real. I was speaking to a country's tax department about a month ago, who once again were asking me to look at some of their architecture. And without going into all the detail, they basically said, look, we're not really dealing with real money here. So if a hacker gets in, it's not really a big issue, because it's not as if they're dealing with real money. I said, well, there's something that you're really kind of missing, with all respect, and that is, there's the intangibles, your name. If the good faith that is applied to your country's tax department is tarnished in any way, no one will use that system. And we all know how the press likes to take small security problems and make them big issues, even if they are small issues. People will not use your solution. So always, always consider the intangibles, like the value of your name. So let's look at some threats. First of all, masquerading, or being someone you're not, you are really not. One of the best ways of getting around masquerading threats is to use strong authentication. For eavesdropping, people sniffing, listening to the wire, you can use encryption. And I was recently talking to a friend of mine about this, who was saying, how can two people communicate securely? And I said, well, you've got to share some form of secret between the two parties, and then you can transport securely. So he said, well, that should be pretty easy. I said, yeah, sure. How do you get the secret between Alice and Bob? And he said, well, I just phoned them up. Okay, well, someone's listening to the telephone. So he looks at me sideways, hey, you're a bit paranoid. Yeah, it's the real world. Sometimes people do listen to the telephone line. He said, I'll email it then. Okay, well, that's worse. Someone could be sniffing the wire again. How many routers does the email go through? Oh, yeah, that's a point. I'll send encrypted email. I'll use S-MIME or use PPTP or whatever. So I said, well, if you're going to use S-MIME, you need a shared secret. How do you get that shared secret between Alice and Bob? At this point, he thought I was as bad as the previous woman I was talking about, whose job I think I ruined. He said, you're just downright paranoid, Michael. Yeah, there are some horrible people out there. So encryption is one way. I'm not going to talk about managing keys in this presentation. That's a whole big rat hole to get involved with. Data modification. How do we know that someone didn't change the order for 100 widgets to 1,000 widgets? And you can use what are called message digests, also message authentication codes to help protect against modification. Replay attacks. So I'm going to transfer $100 out of Van's account and transfer it to my account. Then run the same thing again, and again, and again. Now after about 3 iterations, he's got no money left in his account. So ways around that, things like timestamps and sequence numbers and so on. And finally, denial of service. How do we make sure that no one shuts down your service or denies service to valid users? So now we've worked out like some threats and some defenses and so on. How can we map certain tools onto this? One of the things we're really pushing very strongly in the web space, and definitely in Windows 2000, is certificates and smart cards. For eavesdropping, data modification, and replay attacks, channel-level authentication, protocols like SSL, TLS, and IPsec, for those who were here at the previous session, can also address many of these issues as well. And finally, denial of service. This is really something that's in the realm of filtering, like firewalls and so on. So let's look at a solution. What I want to do is demonstrate to you and show you how to build an easily and securely access remote documents across the web from within Office 2000. The first thing I'm going to say is, oh yeah, this sounds a little bit like Van's presentation. Any of you who went to Van's presentation and saw the Office 2000 stuff, it kind of is, but it's just better. We're good buddies, don't worry. We just give each other a heck all day. Like I say, he's in the office next to me. I kind of get sick of the sight of him. So anyway, some ingredients for a solution. Now, I stress this is a solution. There are many solutions to this problem. So we can look at certificates, we can look at smart cards, we're going to look at SSL, TLS, IIS itself, Office 2000, the Active Directory, and web folders and WebDAV. So how many of you think WebDAV rocks? Okay, there's one. Oh man, we have a disciple over here waving both arms. Good stuff. WebDAV rocks. It's cool. And web folders just make WebDAV that much easier. Those of you who didn't go to Van's presentation, I'll explain it better. So we've got these tools that we can use. So certificate, smart cards, SSL, TLS provide the core security. IIS provides the web access. Office 2000, the DS, and WebDAV provide the ease of use. I mean, historically, you know, all the certificate stuff and SSL stuff has always been pretty technical and pretty hard to use. But with the likes of now Office 2000 and its integration with WebDAV and web folders, it becomes so much more palatable to the average end user. But before I move on, I want to explain some crypto terms, because I'm bound to drop these into the conversation at some stage. Now, this is the only time I think anyone in the history of planet Earth has actually managed to squish crypto onto one slide. As you're probably all well aware, this could be a week-long session. So I'm just going to explain some of the terms. So first of all, symmetric key encryption. This is when Alice and Bob share some form of secret between each other. And the real problem is, how does Alice and Bob get to share that secret in the first place? How does Alice convey to Bob, this is my secret, and now we can use this? And it's actually a real problem, the problem of key management and key distribution. The nice thing about symmetric key crypto is it's fairly quick. In the overall scheme of things, it's relatively quick. And some of the most common ciphers that you will hear of are RC2, RC4, RC5, DES. Any of you who have used Phil Zimmerman's PGP will be familiar with IDEA, the federal government's skipjack. They're all examples of symmetric key algorithms. Then if we look at asymmetric key algorithms, the most common one here by far is RSA, named after the three inventors, Ravesh, Shamir, and Edelman. And this is where there are two keys generated at exactly the same time. They're mathematically related, and here's the key thing, no pun intended, it is statistically infeasible to determine one key knowing the other. If you know the public key, it is statistically infeasible to determine the private key. If you know the private key, it's statistically infeasible to determine the public key, and so on and so forth. Notice I say statistically infeasible. I will never use the word impossible in this presentation. I'm not paranoid. All I'm trying to say is that, you know, in the overall scheme of things, everything is possible. Do you have enough time, money, and resources? If you have all of those on your side, you can probably break some of this stuff. By the way, one thing you'll realize, I always go down to these little rat holes. I'm just going to pop down into one and then come back out again in a moment. But if it costs, I say statistically infeasible, but it's also often financially infeasible. If you're trying to break something, and it's going to cost you $10 million to try and break it, but the data's worth $15.63, Are you actually going to spend $10 million trying to do it? Possibly not. I'm not going to say probably not, possibly not. The other thing is, if the data often has a useful lifetime. To give you an idea, during the Gulf War, the Iraqis were actually cracking the American troop movements, or getting an idea of the Allied troop movements in about 5 days, which is actually pretty cool, except they'd happened 4.5 days ago. So it kind of defeats the purpose. So the whole point of encryption is really to slow things down, just make it harder. And hopefully, the length of time to break the encryption is longer than the useful lifetime of the data it's trying to protect. Now, the most fundamental part that you must understand about asymmetric cryptography is that if you encrypt some data with a public key, you can only use the private key to decrypt it. And if you encrypt some data with the private key, you can only use the public key to decrypt it. You can try encrypting with the private and decrypting with the private, and you'll just get lots of junk, just different junk. Next, we move on to hashing. Now, hashing is not something you can get busted for. This is where you take a document, a big document, and you reduce it to a hash, a smaller number, either a 128-bit number or a 160-bit number. The really cool thing is that it is, once again, statistically infeasible to come up with another document which matches that hash. Not saying impossible, just statistically infeasible. Now, this is the only time I'll ever use the word impossible in this entire presentation. It is impossible to determine the document knowing just the hash, because it's lossy. Now, here's an analogy, a very sad, sick analogy. It's like you lopping off my thumb. Having my thumb identifies me, but doesn't tell you anything that I know, which is probably a good thing. But it certainly tells you, yes, this is Michael Howard's thumb. So this is probably one of the best analogies I can think of. And finally, we get on to signing. Signing is when you take a document, you hash it down to a small number, and then encrypt the hash with a private key. You may think, well, why do you do that? What's the point? Well, the main reason is that asymmetric cryptography is exceptionally slow. To give you an idea, in software, RSA versus DES, give or take, is approximately 1,000 times slower in software. So it's very, very slow. But encrypting, say, a small hash, 128 bits or 160 bits, is actually pretty quick. So it's quite often what you will do is you'll take a document, hash it, and encrypt the hash with a private key. And what that does is it proves, A, that no one changed the document, and B, that it came from you. And here's why. When I receive the document, I rehash the document, take your public key, decrypt the signature on the existing document, and then compare the two hashes. It must have come from you, because you're the only one with a private key. That's why it's called a private key, by the way. You're the only person with that private key, and only your public key, which is public knowledge, that's why it's called a public key, can decrypt it. And no one must have tampered with the document, or it's statistically infeasible that anyone tampered with the document, because the hash is recomputed. So what is a certificate? Well, the main thing about a certificate is that it binds an entity, a user or a computer or whatever, to a public key. In other words, someone has verified that this is you and this is your public key. Therefore, it asserts that you are the owner of a private key, because of the mathematical relationship between these two things. Now, certificates are issued by CAs, certification authorities like VeriSign and Thought, and a bunch of others. And these companies usually have an issuing and liability policy. This is the critical thing. It's very important you understand this. Because people think, well, hey, why don't I just install Windows 2000 or the NT4 option pack, load certificate server, and just start churning out certificates? Well, do you have an issuing policy? Do you have a liability policy? If fraudulent use can be determined of a certificate that you issued, are you going to back it up with insurance? The answer is probably no. Whereas VeriSign and Thought and companies like that certainly do. So certification allows for authentication, allows you to say, is the end entity that I'm communicating with really who they say they are? You may think, well, what's the point of doing that? Well, private communication is a complete waste of time if you don't know who you're talking to, in most cases. Great example. If I'm buying books from barnesandnoble.com, I've got a secure channel between point A and point B, it better be Barnes & Noble and not somebody else. Now here's something that's very, very, very important, which I don't think a lot of people get. So if this is the only thing you take away from this whole presentation, I will die a happy man. And that is, certificates are absolutely public documents. They contain no private information whatsoever. They don't need to be protected at all. I could hand out my certificate to everyone in here, and I will still sleep at night. Why? They are public documents. They're like a passport. So then someone said, well, why don't I just go and change the information in the certificate? Well, you can't, because certificates are hashed, and then they are signed by the CA. Once again, it is statistically infeasible to create a certificate that matches my certificate. Now, the associated private key that's associated with that public key in the certificate is held private. This is the thing you must protect. Now we get into this role of trust. For Alice to trust information in Bob's certificate, Alice and Bob must both trust the issuer. So if Bob gets a certificate from Thought, for example, then Bob had better trust Thought. Well, that kind of goes without saying. But for Alice and Bob to do secure communication, both Alice and Bob must both trust Thought. And having the issuer's what are called root certificates or self-signed roots in your application software, or more accurate, the operating system, means that you trust that issuer. And this is a very, very important issue. When you load IE or Navigator or much software, they come in with a bunch of baked-in root certificates. From some companies I don't even know. And from some companies you don't even know. I'm not going to name any names. Last time I did that I got in trouble. But you should go down that list. And if you don't know who the company is, remove them from the list. Because if you don't know them, how on earth can you trust them? That's the very first thing I do, is I go through the list of all these baked-in roots and then remove them. And it's actually a very difficult problem, because we had to add these baked-in roots to sort of bootstrap SSL. And the real problem is it's not up to Microsoft to tell Ford or GM or AT&T or British Telecom or Deutsche Telekom or whoever who they trust. So it's up to you as IT professionals, as developers, and so on, to make sure that the list of baked-in roots is a list that you trust. So this is what the UI kind of looks like. The top UI is now in IE, and the bottom one is the MMC UI that is in the console inside of Windows 2000. So I hope you can see it. There's a list of roots in here, and if you don't know who they are, delete them. Click on them, remove. Just get rid of them. So let's look at the certificate lifecycle. This seems to confuse a lot of people. So lifecycles have a history. Like they have lifecycle. Certificates have a lifecycle, have a history. So the first thing is your software generates some keys, public and private key pair. You create a request. That request is often referred to as a PKCS10. It's the standard format for a certificate request. You send that to the CA. The CA then verifies you are who you say you are. They then create the certificate, send the certificate back to you. You add that to your certificate store. At that point, either you or the CA can publish the certificate. Now, remember, a certificate is public information. It can go basically anywhere. For example, if I get a certificate from VeriSign, they will automatically add me to their list, and anyone can go to VeriSign's website and query for Mike Howe at Microsoft.com and bring my certificate up. Click on it, download the certificate to their machine. They can now go into, say, Outlook, for example, and send me secure email. So go ahead and do it. Go to VeriSign, query for Mike Howe at Microsoft.com, get my certificate, and just send me some email, encrypted email. And in the case of the Active Directory, if you're running Windows 2000 and you have certificate services installed in enterprise mode, when you enroll for a certificate, we will automatically add the user certificate to your node in the Active Directory, to your user object. So anyone can just do an LDAP query, for example. Now later down the track, you may have your private key compromised, or you may change companies, so the certificate may become revoked. I'll come into that in greater detail shortly. So how does your software check that a certificate is actually valid? Well, first of all, your software checks the certificate's valid by, well, is it trusted? Do we actually know who signed this? If the answer is no, No, no connection. Is the signature okay? In other words, has anybody tampered with this document, this certificate? Then we check, are the dates valid? Certificates have a valid from and valid till date. And with most client certificates, that is around 1 year. Now, this is actually a very, very common support call for Windows NT 4 option pack. So I'll quickly explain this problem here. The scenario sort of opens itself up like this. I have IIS, certificate server, and a browser. IIS, enroll for certificate using certificate server. The certificate server machine has its clock set 10 minutes in the future. But you don't know that, of course. IIS then gets the certificate, you do all your stuff, and then you go and connect from the browser. And the browser fails the connection. And you wonder why. Well, the reason is the certificate will be valid in another 9 minutes. It's not valid yet. So the secret, and it'll become a bigger issue with Windows 2000 because of Kerberos time synchronization, is make sure your clocks are synchronized. Now, I already touched on the certificate revocation. Sometimes a certificate becomes invalid before it expires. A great example is the private key is compromised, the person changes affiliation, that just means they got sacked, they got fired. And in fact, when a certificate is revoked, you can actually associate why the certificate was, or more accurately, the private key has been revoked. You can actually associate why it was revoked. And there are some people in the industry who think, that could be a privacy issue. Imagine if I went to a company and found out that, let's say for example, that VeriSign keep track of why a certificate is revoked. And let's say I understand that these guys at Foo Corporation, they're getting a lot of client certificates from VeriSign. What is preventing me from going to VeriSign and saying, why are all the people from why are the private keys being revoked from Foo Corporation? And I find a lot of them are change affiliation. It looks like they have a very high staff turnover. This could be a privacy issue. Now, I'm not paranoid or anything, but it's one of those little tidbits of information that you can use when you're building up an attack against a company. So a certificate itself can contain what's called a CRIL, or a pointer to the CRIL, often referred to as the CRIL distribution point. The certificate revocation list distribution points. In other words, when you get me, here's where to go and check to make sure I haven't been revoked. So some of you are probably thinking, well, hold on a minute, can't someone just change that? Well, no. If someone just goes and modifies the certificate to contain something else, the hash changes, the signature changes. We can immediately say, hey, someone tinkered with the certificate. Then applications can check with that CRIL to check whether the certificate has actually been revoked or not. So CRIL is issued regularly by the CA, and that is completely determined by the CA's policy. For Class 1 certificates from VeriSign, they're updated every 10 days. An application can poll for the CRIL, and then we'll usually cache the CRIL until it expires. And you can use many different protocols to actually get hold of the CRIL itself. For example, in Windows 2000, it can be a file location, it can be an HTTP location, and it can be an LDAP lookup. And here's a real-life CRIL. Just go to cril.verisign.com, and you can download the CRILs. And this is all in the UI. Just double-click on the CRIL, and that will pop this UI. So moving along to certificates, and more accurately, certificates in Windows 2000. Windows 2000 has superb support for certificates. We included Certificate Services 2.0, there's auto-enrollment for computers, there's easy enrollment for users. When I say easy, easy is a relative term. Relative to what we had in Windows NT 4 option pack, it's easy. Very tight integration with the Active Directory. The reason is that X.509 certificates, which are the standard certificate formats on the web, work very well in directories. The reason why? Where do you think the X.50 bit came from in X.509? X.500. Now, whether that's a good thing or a bad thing, that's where the X.509 certificates came from. And finally, we have really good support for smart cards, the encrypting file system, and IPsec. As I've already mentioned, when you enroll for a certificate in the Active Directory and you're using certificate services installed in what's called enterprise mode, when I go through the enrollment process, certificate services exit module will automatically post my certificate to my user object in the Active Directory. It just happens. No rocket science involved. It just happens. And there's a thing called the user certificate attribute. Now, for those who really want to know, here's a little bit of script which will get the certificate for a particular user who happens to be in the squirt.mikehow.nttest.microsoft.com domain, and I'm looking at the administrator account in the user's container. And I'm just going to get the user certificate object, and that's it. I now have that guy's certificate. Simple as that. So let's look at an example scenario. I found this scenario to sort of concrete in people's minds just how this stuff kind of hangs together. So I hope it does for you too. So we want all these things, all these like certificate services, Windows 2000, Exchange and Internet services and IE and Outlook and so on, to build a very secure environment. Well, it all starts at the very top. If we have certificate services installed, everyone must trust this root. If no one trusts that root, or not everyone trusts the root, the whole thing kind of begins to break down. So what it really means to trust that root is to add that root certificate to the operating systems of all the machines. So once when I gave this presentation, or a presentation kind of like this, this is another one of those rat holes I'm going to go down. This was actually in Palm Springs at Web TechEd. And a couple of friends of mine from VeriSign were in the audience. They're actually in the about here, sort of staring me down. And this guy at the back says, well, hey, hold on a minute, how do I know that the roots that you include in IE are the VeriSign roots? One, I was like pretty happy that he was asking this question because it showed that a bit of paranoia was rubbing off on him. So I said, well, just trust us. So everyone in the audience laughed. I thought, okay, well, that one didn't work. Okay, simple. Go to VeriSign's website. They have the roots there. So I was about to start the presentation again, and up goes his hand. How do I know it's VeriSign's web server? Okay, I can play your games. Phone up VeriSign and get them to send you the roots on a floppy. And I can see these two friends of mine like in the front. Oh no, here we go. They're looking around. Yeah, how many people are in the audience? Oh no. And then they realize there's like video cameras at the back as well. You know, this thing was going to go on Microsoft.com, and here I am saying, just go to VeriSign, no problems. So, and the guy says, okay, so how do I know I'm really speaking to someone at VeriSign when I phone them up? Okay. Just assume it's VeriSign, okay? And then get them to send you a floppy with the roots. So about to start the presentation again. Up goes his hand again. This is a true story, by the way. How do I know that someone didn't intercept the envelope on the way, swap the roots over on the floppy? I felt like saying to this guy, do you want a job? So I said, well, look, when you get the floppy, load them into IE, double-click on them, and up will come two hashes, an MD5 hash and a SHA-1 hash. Phone up VeriSign and ask them to read back the hashes. By this time, these two guys from VeriSign were just crying. Oh no, they could just imagine the support calls right now. So, then he says, you know, I really don't know. I'm not really happy that this is really VeriSign I'm speaking to. I said, okay. I would recommend at this point, sir, that you don't do any business on the web. And then his hand goes back up again. You still haven't answered my question. I said, okay, here's the last answer. Fly down to California. Go to VeriSign's offices. Walk into the lobby. Ask for the chief technology officer and ask him to give you the roots on a floppy. And by the way, if you stick your hand up once more, I'm going to personally walk you out of this presentation. So there are degrees of paranoia. This guy was scary. So anyway, everyone must trust the root. Very important. So let's look at a scenario. So first of all, we have IIS. So we can issue a server certificate. And you'll notice here that this little sort of diagram thing explains that this certificate is actually issued by the root. And same with Exchange. We can give a server certificate to Exchange. We can also give client certificates to IE browsers, so we can authenticate the client. And we can also give Outlook 2000 clients and other clients as well, which aren't as good, certificates for using for S-MIME, for example. Now we have all this in place. The browser can now do SSL, TLS communication to IIS. Actually, let me be pedantic here. You do not need a client certificate to do SSL to IIS or any web server at all. The only reason I'm saying we have a client certificate in IE is if the server has the option during the SSL, TLS negotiation to say, okay, you now know who I am, I now want to know who you are. Give me your certificate. And that's an optional part of the SSL, TLS handshake. So in paranoid environments, that's possibly what you may do. And also, I can do secure POP3 and secure SMTP over secure channels, and I can do S-MIME with these certificates. And once again, just to be pedantic here, to do the POP3 and SMTP over SSL TLS, only the server needs a certificate. You do not need a client certificate at all. But to do S-MIME, you do need the client certificate. The reason being is that you're possibly going to be encrypting a blob which is on your machine. It's then going to go through Exchange or through SendMail or whatever out to the other end where the certificate will be used as well. So to actually do S-MIME, an Exchange server or a SendMail server or whatever does not need to have a certificate. It just sort of routes the certificate through it. Then we get on to certificate revocation lists. And once again, the CRIL is signed by the CA, by the root. And then we can issue the CRIL to all the machines. At this point, for example, my IE browser, when it communicates with IIS, can check with its CRIL to make sure that this certificate has not been revoked. And more importantly, you may have only a few of these, but you may have many thousands of these, browsers that is. So if you're using client certificates, IIS can say, hold on a minute, you've given me your certificate, let me just go and check that it hasn't been revoked. And it's the same with Exchange and the same with Outlook. So a couple of little rules of thumb. First of all, you can be authenticated if you have a certificate and the associated private key. And you can send encrypted email to somebody if you possess the recipient certificate. Think about it for a moment. Why? The first point, you can be authenticated if you have the certificate and you have the private key. When you send a blob out, you encrypt. This is a very broad generalization, it's technically inaccurate, but I encrypt the message with my private key. When the recipient receives that blob, they can decrypt it with my public key. It must have come from me. It can't have come from anybody else. Or it's statistically infeasible that it came from anybody else. You can send encrypted email to somebody if you possess their certificate. Why? I encrypt the blob with their public key, which is in the certificate. Only they have the private key, hence they're the only person who can decrypt it. I say it's technically not right because you do not encrypt the entire message, because it's just too slow. So now let's move on to some ingredients. Smart cards. I'm sure you're all familiar with smart cards by now. If you're not, you're going to be sick of them by the end of the session anyway. Smart cards. I could be holding a credit card up, you wouldn't know. They're credit card size devices, have microprocessors, memories, blah, blah, blah. The nice thing about them is they require possession of something you have, and something you know, a PIN. The demonstration I was going to give actually was going to use the smart card, but for reasons beyond my control, it's melted, so I'm going to have to use normal certificates, not smart cards. And you can also use the Windows 2000 Active Directory because of this user certificate attribute that I mentioned before. IIS is the web server with Windows 2000, superb support for certificates, and we also now have web dev support. Web folders absolutely rock. It's one feature that I think when everyone sees, if you've not seen it, you'll be completely sold on. It's absolutely awesome. It's basically seamless connection to documents on a web server over DAV. You can drag and drop files, for example, from the desktop, and you treat them as though they're local. And it's built into IE5, Office 2000. So if you have Win9X or Win98, Win98, Windows NT4, Windows 2000, you get WebDAV if you have IE5 or Office 2000. And Windows 2000 Beta 3 has web folder support built into it as well. So what is WebDAV? I'm not going to spend a lot of time on this because Van can certainly do a much better job than I can. Can't believe I admitted to that. Basically, it's web distributed authoring and versioning. Well, the joke within the company at the moment is it's WebDAV because the versioning isn't quite there yet in the actual protocol. It's a standard set of extensions to HTTP for web publishing. That's probably the simplest way I can think of defining it. And they're just really just a bunch of new methods, so new headers to HTTP 1.1, and it's now in RFC. I'm not going to go into any great detail, but these are some of the new headers that have been added. Putting a document already exists in HTTP 1.1, deleting exists, moving, locking and unlocking. By the way, something you should know about. Any of you guys want to experiment with this stuff with Office 2000 on Windows 2000 Beta 3, there is a little feature which you should be aware of. If you have a document open in say, Word 2000, and you just shut down Word, and you have the document still there, we will maintain the lock for 30 seconds. Yes, it's a little feature. It will be removed by the time we ship the product, but just to be aware of. So just wait for 30 seconds and the lock will become free. It's actually Van's fault. So let's look at this sample scenario. So let's say I've got a bunch of products, say Office 2000 products, Word, Excel, PowerPoint, and so on. And I create some documents, and I can write those securely to a web folder. I see a web folder on my desktop, or inside of, say, Word, I can actually see the web folder location or my network places. And all this is secured because I logged on using a smart card and I'm using my certificate. This goes across the web, over using WebDAV over a secure channel, out to my IIS server. And the way I get to it is by typing in https:// whatever the server name is, whatever the share name is. And I've configured IIS to require a client certificate from a bunch of people or a bunch of CAs that I trust. IIS will then write out the documents to the appropriate location on the local hard drive. Then I can lock that puppy down using ACLs if I wish. So this is how you set the demo up. This is how I set the demo up. You install Windows 2000 Beta 3, install Office 2000, get a server certificate for IIS. So if you've got certificate services installed, you can experiment yourself. You issue a client authentication certificate to a client smart card if you're using smart cards, or you can just make it a normal client certificate. You set up a secure location on your web server for the documents. You then set up a web folder on the client, and that's it. This is how we do it. First of all, the certificate side of things. We've actually made it palatable now for human beings. First of all, the good news. Actually, how many of you used keyring in IIS 4? Quite a few. How many of you survived? Much less. Well, the good news is keyring is dead. Keyring is no more. We now have this new tool which is infinitely easier to use, which allows you to enroll and actually manage the certificate lifecycle much better than keyring ever did. And enrolling for client certificates is a lot more intuitive now as well, if you want to use the ASP pages, for example. The new certificate services toolset, which are built into the UI using MMC Snap-in, allow you to do everything you'd ever want to do with certificates. You know, the full backup of the database, revocation, filtering, full support for hierarchies. In the labs at the moment, we've got something like 30-odd levels of hierarchy being tested. Works fine. And that's all available from within the UI. Historically, this was very, very difficult to do. Setting up the server is simply a case of going to the IIS snap-in, right-clicking on the location where you want to dump the docs, bringing up the properties, directory security, and saying, I require SSL and I require client certificates. And then if you wish, you can also enable certificate mapping. If you want to map directly onto the certificate straight onto the Windows 2000 principal, you just say enable directory mapping. And what we will do is we will automatically negotiate with the user certificate associated with that user object. There's no other setup you need to do. You just click on a button that says use directory mapping, and that's it. Setting up the client is pretty straightforward. You go to My Network Places, or this is one way of doing it. Okay, let me be absolutely honest with you. This is not the way to do it. There are some little features in the shell today where I'm going to show you how to do it or explain how to do it, but in reality, I would not do it this way. This is how you're supposed to do it. You go to My Network Places, click on Add Network Place, and type in https:// name of server, name of location. And then you will have a new web folder. Whenever I drag and drop things to that, they will go over IIS through a secure channel. It will prompt me for the password, for the certificate. If I'm using a smart card, it will prompt me for the PIN, and then it will transfer the documents. Now, the recommended way of really doing it is to go into IE, go to File, Open, type in https:// blah, 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 blah. There's a little checky box, Open as Web Folder. Click on that, then click OK. And what that will actually do is it will also set up this folder for you automatically in the UI. There are some little issues at the moment with it being done in the UI. If I remember correctly, and Van, please correct me if I'm wrong, the shell does not respond to HTTPS. It's only HTTP at the moment. It's a bug. It's going to be fixed. So the workaround is go into IE and do it that way, as I just mentioned before. Same result. So using the scenario, well, one thing I can do is drag and drop a document from the desktop into this folder, and it will go over the network, over a secure channel, prompt me for the client certificate, blah, blah, blah. Or in Word, I can just do Save As. Go to My Network Places, and you'll see shared on MikeHow 2000. That is my network location. That is my folder, my web folder. So what really happens when I save a file or I drag a file into a web folder? Well, first of all, the shell works out the location, sees that it's HTTPS, etc., establishes an SSL connection to IIS. IIS then says, well, hold on a minute, we require a client certificate because that's how you configure the web server. The UI will pop up with a please select a client certificate to use. If you're using a smart card, you must then type in the PIN. Then it copies the data to IIS using WebDAV over HTTPS. So it's a nice secure channel. And then finally closes the connection. That's how the whole thing works. So demo. Now I put this little image on here when I was doing the demo, like shoot me. Because if it wasn't for the fact that I was talking to Van yesterday, this demo would not be happening right now. There's some little problems. I was doing mine was very UI focused. Sorry, shell focused. So if I load up Word, and I go File, Open, you see I've got My Network Places. And I got shortcut to foo on MikeHow NT5. Open that. And say, well, hold on a minute. Before you get in here, tell me who you are. I've got 2 certificates on my machine. So I use my Michael Howard certificate. For those of you who have not seen the new certificate UI, it's pretty funky. It rocks. It's a really cool UI. I say, okay, that'll do. That one will do. Now I'm paranoid. So I've got my machine configured so that if any application tries to touch my private key material, this dialog box will pop up. So I know that anyone's trying to touch my private key. Now in here is a bunch of documents. foo.txt, hi.doc, speakpacket.doc, and so on. So I'll open hi.doc. And this thing up here shows that it's doing webdav. Okay, so I'm trying to use my private key again. Let's try that one again. Oh, great. Well, this is the Cyrillic version of the document. Hold on, let's try this again. File, open. My network places. Okay. It worked yesterday. It worked real good too. Let's try it once more. Once more. By the way, if this doesn't work again, blame Van. It's his stuff. Yay. So what we just saw then was a couple of problems that need fixing. Was Windows 2000 using IIS 5 client certificates, was using WebDAV and web folders. The last two you didn't even realize you were using. As far as you were concerned, you were just like opening a document from somewhere. You didn't realize it was actually across an SSL connection to a web server. Now, I'm not doing any more of the demo. Okay, so some more resources. First of all, there's a presentation I put out on the web called Fundamental Cryptography and Certificates. This is one I gave in Palm Springs at Web TechEd a year or so ago, or however long ago it was. And basically, it's a complete end-to-end explanation of cryptography with a lead up to certificates and why they're goodness, why they're a good thing. And that's available as a net show presentation, and I certainly urge you to have a look at it if you want to learn a little bit more. Is that a question? Sure. Okay, I probably won't be able to hear you very well. The question the gentleman asked is why am I going to a web server rather than just say to a file server? Well, the really cool thing is it works extremely well across the web, extremely well. I mean, we've always been able to get documents across the web, right? That's what HTTP is all about, just pulling things down. The big difference is with DAV is that I've got things like locking and unlocking and being able to query on properties and so on and so forth. Now, yeah, those are available on file servers as well. But the nice thing about WebDAV is that it's a standard which more and more people are beginning to support. I mean, for example, IIS 5 ships it now. You can play around with it in Windows 2000. Apache supports it with ModDAV. I'm not 100% familiar with their implementation. It's just a nice, clean, industry-standard way of accessing a document. Now, probably the best thing to do, in all honesty, is speak to Van at the end. He can give you the full lowdown as to why this is a really funky thing. Digital Certificates is also worth looking at. It's a very good book. It's probably the only book I've ever come across that really explains certificates very well. Most books on certificates are pretty bad. This one's a pretty good book. And Applied Crypto by Bruce Schneier is also a good book if you want to get a good handle on crypto in general. Now, it says go to the WebDAV talk by Van. Well, this was actually done before all the timelines were organized. So slight modification to that is see Van at the end. He can talk to you about this stuff. So call to action. Use Windows 2000 Beta 3. This stuff is actually pretty solid in general. The PKI integration is excellent. The smart card integration is excellent. Really start to learn about certificates. When this puppy ships, there's going to be a huge groundswell of interest, especially with the Kerberos integration and so on. So really learn about the PKI stuff in Windows 2000. And finally, really experiment with IIS, Office 2000, and WebDAV. Now the next slide I kind of added for a bit of fun. Throughout the presentation, I made reference like the Squirt CA and to squirt.mikehow.nttest.microsoft.com. So you're probably thinking, what on earth is Squirt? Well, I'll show you in a moment. But a quick summary. IIS 5, Office 2000, Windows 2000, Certificate Services, and WebDAV makes it pretty easy to build and deploy and understand security solutions. So for those of you who really want to know who Squirt is, now let me explain something. Squirt is my CA. Squirt has a very, very simple policy for who he issues certificates to. And it's this. If you let him lick your face, you can have a certificate. If you don't let him lick your face, you don't get one. That's his policy. And there is no insurance. So with that, I've left lots of time for questions. There's always questions in these sessions. So feel free, there's a microphone right here. Thank you. Yeah. Someone turn the mic on? Anyone in charge of this mic? Do you want to start with the questions, and I can actually repeat the question back? Mallet. Mallet. The question is, what's some good books on learning about Alice and Bob and Mallet? Alice and Bob has been around for a long time in certificate and cryptography circles in general. The most popular book by far that explains it all is Bruce Schneier's Applied Cryptography, which explains it very, very well.
Yeah, two quick questions. What's the status of the FIPS 140-1 compliance? And will the PKI infrastructure here still work with Site Server 3.0 and Commerce Server if you have the web security set to the membership and personalization service?
Okay, two questions. First one, what's the status on FIPS 140-1? Well, the first thing is we've done is IIS 5, IE5, Windows 2000 will ship with Forteza support. That's the first thing to get us there. We will be shipping a crypto service provider from Spirus, which will give us Forteza support. So that's the first step. As for FIPS 140-1, different product teams are in different... Actually, let me back up. In Windows, there is this DLL, this one single DLL called schannel.dll. It does all this stuff. So for example, for the FIPS 140-1 support, all we have to do is just make the modifications to schannel. That will be a wonderful thing. The problem is the guys who do schannel are completely swamped at the moment. And it's just a case of just doing it. It is absolutely on the boards to do. And all we have to do is modify schannel. And then possibly make some slight modifications to IIS, but generally we don't really have to. And then in theory, it should just all work. If you want more information with a rough idea, real rough idea of timelines, just come and see me up at the end. I'll give you a feel for where different products are. But the key thing is we make the mods to schannel when it's all done. And as for the membership stuff, I'll be honest with you, I'm not a great expert in membership server. My understanding is that yes, they will use this PKI infrastructure that's in Windows 2000 because they have their own certificate mapper, which they can use.
Hello, yes, for intranet use, is a certificate authority suggested?
Is a certificate authority suggested? That really boils down to a policy issue in your company. I can't answer that question. If the CA is protected, the keys are well guarded, possibly in hardware, if you've got a big guy on the door with a gun protecting it, probably. It depends. If you're committed to a PKI infrastructure, more than probably. But the thing you have to remember is if that puppy gets compromised, you could be in for a lot of trouble. Especially if your certificate revocation list delta is like 10 weeks, then someone could in theory start doing naughty things on the net for 10 weeks until it gets found out. So Like everything in security, is like yes and no. Personally, absolutely. I think that's probably the answer you want. Next, yeah.
Hi. If I read you right, one of the main weaknesses of public key cryptography is that it's very slow.
Sure.
Are there any weaknesses to the idea of using public key cryptography to send a symmetric key and then use a symmetric key to encrypt the whole document?
You've just invented most of the algorithms that are out there. SSL does that, TLS does that, SMIME does that, SET does that, they all do that. When I said before, you know, I can send an authenticated document to you because I encrypt it with my private key, then you decrypt it with my public key, and I said at the very beginning, I'm really kind of lying. What really happens is I sign, let's say you and I want to communicate. What I will do, this is like a 40,000 foot view, is I'll come up with a random key, encrypt it with my private key and send it, sorry, with your public key, because I have it. Only you can decrypt it with your private key. We now have a secure key. So yeah, you've basically just invented something that's actually very, very common. Yeah.
During the presentation, I think you mentioned that the clients would download the krill from the certificate authority. Over time, how do you stop the client from becoming overwhelmed or swamped with these krills?
Good question, excellent question. Now, I want to get you to put your thinking cap on for a minute. Krills only contain the serial number of certificates that have been revoked, not expired. So krills don't get arbitrarily big, because once you get to a point where the krill has actually expired, sorry, the serial number of the certificate has expired, it gets removed from the krill. Now, there is a little law in what's called the PKIC standard. PKIC is Public Key Infrastructure on X.509 certificates. It's like the standard. It has just become an RFC after going through the working group for the last gazillion years. They say that thou shalt add the serial number for an expired certificate for one more rev of the krill. So if the krill distribution point delta, or the krill delta is 10 days, and your certificate is on the krill, because it's been revoked for some reason, then it expires here. It'll be in the next update, and after that it will be purged. Because technically, the software, when it sees the certificate, doesn't have to do a krill check. It's expired. The certificate has expired. It's not valid anymore. So the krills don't get arbitrarily big.
I have kind of a web dev question,
Okay.
so maybe Van will answer it. I'm curious, when will versioning actually be a part of the protocol? Reason being is right now the user would need to understand the structure of the directory in which they're copying the file to make sure other people would be able to use it via links in a browser, etc., as well as sort of management of content from an intranet standpoint.
Right. To be honest with you, I've got no idea. Van's the guy, probably doesn't know either. But that said, I actually don't care about the versioning stuff. I just wish they would add the ACLs to WebDAV. This is a classic example, right? I mean, I'm not cynical or anything, but you probably detect a hint of cynicism. They did this stuff and then said, oh, we'll add ACLs later. So I'm more interested in the ACL stuff. But see, Van is still down there yapping away in red. Talk about the V part of DAV. Thanks.
I want to get some understanding of certificate authorities and issuing certificates. As a manufacturing company, I want to be able to do secure communications with my vendors. Do I have the power to create my own certificates that are, does my certificate server have some kind of, if I get a certificate from VeriSign, can I create my own certificates, or do all my users have to go to VeriSign to get their certificates to do this?
Great question. I was waiting for this one. Every single conference we have this exact question. The answer is one of trust. It really is. Basically, people trust VeriSign, they trust Thought, and so on, because their whole business revolves around trust. And also the fact that IE and Netscape and so on come with the baked-in roots for VeriSign and Thought and so on makes it so much easier. So the question really is, if you want it just to be dead easy to use, go to VeriSign or Thought. Okay, there's nothing you need to do in the browsers, nothing you need to do in the servers. It all just works. However, some people want tighter control over it, like who they issue to and when they issue and so on. In which case, you may want to install certificate services. The problem now that you now have, however, is that you have to convince your business partners to trust you, which means loading your root certificate into their browsers and so on. And that's probably pretty easy to do, actually, because if you already have a business relationship, you know, Fu and Ba are already doing business, they have been doing for the last 10 years, they probably trust each other. Therefore, you can probably quite easily say, look, we're going to go to the next level. We're going to start doing, let's try and load as many buzzwords as possible. We're going to do XML over, you know, secure communications using X.509 certificates. Let's take it to the next level. Let's automate this whole thing. You can probably tell them, look, to do this, because we're going to be doing it with our other partners, you need to trust us as a CA. And we will issue smart cards, for example, to say your procurement officers or whatever. So as long as you have the business trust there, you probably can do it. Now, the next possibility is to get VeriSign or Thought to certify you using what's called cross-certification. So let's say you two gentlemen wish to do business together. You don't really trust him. I mean, you do, but you know, you don't want to get into the hassle of like loading his root certificates. What's a root certificate anyway? What you could, in theory, do is get VeriSign to certify you, so then you become what's called a second-tier root. So you're now issuing certificates. When his software goes to check your cert, it's actually walking all the way up to the VeriSign root. And as long as it trusts that, it should be pretty much okay. The big problem, however, is that that is actually a very, very difficult exercise to go through with any CA, because they have to, you have to be audited. You have to make sure you have the correct infrastructure in place to protect any keys, and so on and so forth. So I hope I didn't like confuse things anymore, but that's certainly an option.
Just want to see if I understand. You said the certificates for authentication are stored in the Active Directory in Windows 2000. Is that correct?
The certificates for authentication are stored in the Active Directory. A lookup or a copy of the certificates is stored in the AD. Absolutely, yeah.
Is there a limit to how many can be stored there?
No, the limit is purely as big as it gets. I mean, a certificate is approximately 1K in size. They're not that big.
And you can restrict access to your folders and files using those certificates?
Using certificates? You can certainly encrypt. You can't set ACLs based on a certificate, but you can certainly see, because we can map a certificate onto a Windows NT principal, a user, for example. Then you can say, okay, this user has access to these resources. The fact that the credential came from something they had on a smart card is really irrelevant, but certainly you can do it that way, yeah.
To do the ACL management?
Yeah, you don't do ACLs based on the contents of a certificate. You do ACLs based on a principle. And it just happens that the certificate is used as credentials to prove that the principal actually is who they say they are. But the ACLs are actually, you know, principal and what access they have to a resource. The principal was determined perhaps by a Kerberos logon through a Windows NT challenge response logon, or from a certificate, or yeah. If you're not 100% sure what I'm talking about, just come and see me at the end. You basically don't say, here's a certificate. Someone who has this certificate has access. That's not the case at all. You say this principal has access. You may have derived that principal from the certificate.
Okay, thanks.
I don't know if that helps.
Two quick questions. First one's on what you just mentioned earlier. Are there any standards on establishing a root CA?
Are there any standards on establishing a root CA? None that I'm aware of. You could take what VeriSign say you should do and what Thought say you should do, and take those like de facto standards, because possibly they are, because that's what they say you must do if you want to be a root or a cross-certified root. That's the only thing I can think of. I don't know of any standard that says this is what you should put in place.
The second question is, in the current white papers on Windows 2000 PKI, it recommends a hierarchical CA. setup. Why, and are you going to do anything more in that, especially about scalability for that? I mean, is scalability the reason you do that?
Actually, the good thing about certificates is they scale exceptionally well because you never, ever, ever go back to the certificate server that issued the certificates. The only time you ever do is to get the krill when it gets updated. So there's no need to like go back to domain controller every time to verify that Fred really is Fred. So they actually scale incredibly well. The reason for hierarchies is one of management, and the other one is that what you often do is you have a root that is like Uber root, like the root. Then you have like say 3 subordinates, which could be subordinates based on location, or they could be subordinates based on usage. Because certificates can be marked for certain usage. So for example, you could say, okay, here's Uber root. It has now signed some sub CAs. This guy can issue email certs. This guy can do client auth certs. This guy can do server certs. Now you imagine if all of a sudden there was a compromise of your email CA. You revoke that certificate. Everything else just keeps working. Now you imagine if it was like a flat hierarchy, and all of a sudden just like that one key is compromised, then the whole thing completely breaks down. So it's a way of just spreading out the workload, and you may want to segregate it by certificate usage. It just makes sense in some cases.
Let's say I wanted to let remote users access files through a web folder. Could you just review real briefly what my options for authentication and security are?
Sure.
Through HTTP?
I mean, basically everything that's in Windows 2000. I mean, if you come in, say, through RAS, they're subject to all the Kerberos stuff, all the NTLM stuff. You can log on using a smart card over RAS. If they're coming in just straight over the internet, you can either have nothing at all, so everyone can access the documents, or you go all the way through to requiring basic authentication, to digest authentication, to requiring a client certificate, to requiring a client certificate on a smart card. And then requiring a client certificate on a smart card and mapping to a Windows NT principal. You can do the whole gamut, the whole gamut. You got a lot of flexibility, which is both good and bad. If you have any specific issues, come at the end and I'll. So I didn't. Do you want to come up to the microphone again? I didn't quite catch that.
What would you do?
What would I do?
If you were in charge of it.
Well, I'm paranoid. Don't ask me. Normally, for examples that I've put together for people, have been smart cards, because it's just easiest to deploy. People understand, I have access because I put this thing in this hole. Whereas when a dialog pops up and it says, please enter an oofablufen, they've got no idea what they mean. So it's actually an ease of use thing to start off with. And the next thing is much, much, much more secure. And the counter argument to that is, well, it's more expensive. Sure it is. But what's the value of the data you're trying to protect? That's the critical thing. If it's like really cheap throwaway data, just use basic authentication over SSL. I mean, it's not rocket science. But if the data is critical, then use something like smart cards. Now, what we recommended in the past for things like banks is they say, if you come in through this part of the namespace, the web space, and you're authenticated using basic over SSL, because passwords can be easily spoofed, anything that comes through this part of the namespace can only do this much stuff. Like, you can only move $1,000 around. But if you come in through this namespace using a smart card, you can do this much stuff because the credentials are that much more stronger. So that's the way I like to look at it. Look at what you're trying to protect, what the risk is of damage to that data, and then find something you think it gives you a good comfort factor in terms of authentication and access control. And then you got sliding from everywhere from anonymous all the way through to smart cards, and a whole rainbow in between. In fact, myself, Mark Levy, and Richard Waymire are giving a presentation next Friday, 2 back-to-back presentations on building secure apps using SQL Server, Com+, IIS, Windows 2000, and so on. We'll actually go through the authentication schemes and so on that are available to you.
Where are the private keys stored if they are not stored on a smart card?
The private keys are stored in what is called what is known as Windows protected storage. It's a secure. It actually depends on the crypto provider. That's the actual. That's actually technically the correct answer. Now we ship some default providers, and those default providers store the information in the registry, and that information is protected by Windows. It's an operating system level protection mechanism that's encrypted with information that's held by Windows. But it depends on the CSP.
Yeah. My company is running an intranet not connected to the internet, so we can't connect to RSA or VeriSign. So can we install the certificate server ourselves and create our own certificates internal, or do we have to have a connection to either RSA or VeriSign?
You can do it all internally.
Just internal?
Absolutely.
Okay.
Absolutely.
Thanks.
You talked about auto registration of certificates for machines but not users. Why did Microsoft take that approach, and is there any plans to have auto registration of certificates for users?
It was actually on the boards to do. In fact, it was actually being developed, and we decided to cut it. It was one of those things where we thought, how long is it going to take? And in a meeting one day, someone stared somebody down and said, "Are you willing to hold up the whole of Windows 2000 for this thing?" But that's basically it. It got cut. But it's still on the board. It's still on the drawing boards to do for a future version. So there is actually an issue there as well. Sorry, there's actually another issue there as well. I'm not a big fan of auto-enrollment, because the whole point of giving someone a certificate is that you've verified who they are. So if I just say, yeah, anyone who comes in, just give them a certificate, that's like anonymous security almost. You know, yeah, no problems, just have a certificate. Yeah, hand them all out. So there's a counter argument to that.
With the new advancements in security with Windows 2000 and IIS, is membership server still necessary, or?
Membership server actually solves different problems. My guess, and I hope no one from membership's here because they're going to not like what I say next, but my guess is the Active Directory will become more and more important. Read into that what you will. That's my guess. Okay, thanks.